Hello, my dear student. Mr. Kitwala from Educare. I will be with you in physics for Form 5. And today, my dear student, we are going to proceed with our topic of rotation of a rigid body for our new subtopic of which is called the angular momentum. This is what we are going today to start a new subtopic which is called the angular momentum. So, my dear student, as we tried to see on the previous period, we tried to look for the 5 subtopic of this topic here about the topic of rotation of a rigid body. Now, we are trying to see some concept related with the talk, some questions related with the talk, the way we can identify the linear acceleration, the way we can identify the linear velocity. That is what we tried to see on that subtopic. But for our today discussion here, we are going to see about the angular momentum. This is not a new term for you as a Form 5 students, my dear student. How can we define the angular momentum? So before we get the meaning of the angular momentum, we were supposed to know the concept of the linear momentum. So according with our statement here, say that when an object rotates about an axis, it is rotational inertia can be described using the angular momentum. If we have an object and that object rotates about an axis, it is a rotational inertia. It is rotational inertia can be described using the angular momentum. Kwa object yoyote ile inapokuwa inazunguka kwenye ile axis, ile rotational inertia, it means rotational inertia, tunaipata kwa kupitia hii angular momentum. This is what we try to see on our introduction of the angular momentum. So angular momentum is represented by letter L. Kwa tuna represent ile angular momentum kwa kutumia letter L, my dear student. And sometimes we define this angular momentum by saying that this is the moment of linear momentum of a body rotating about a fixed axis. This is the moment of linear momentum of a body rotating about a fixed axis. Kwa ile moment of the linear momentum when the body are rotating on its axis, tunaita ni hii ni angular momentum. So you'll be asked to define the angular momentum. So you can say that this is the moment of the linear momentum when the body are rotating on when it is rotating about a fixed axis. So it is the vector quantity with the direction along the axis of the rotation. Kwa ile vector quantity au sometimes tunasema kwamba hii ni vector quantity ambayo inakuwa kwenye direction along to the axis of the rotation. This is what we try to see about the angular momentums. So mathematically, how can we represent the angular momentum mathematically? So mathematically, we say that this linear momentum, my dear student, can be expressed. This angular momentum, can be expressed as the cross product of the vector from the axis of rotations. Kwa tunasema hii tunaipata ni a cross product ya ile ni cross product ya ile position of the vector from the axis of rotation to the particles and the linear momentum. Kama tunavyoona kwamba tunapata hii angular momentum kwa kucross yule radius pamoja na yule linear momentum. So if we leave with that discussion, the definition here, we could say that also this angular momentum, which is represented by letter L, is defined as the cross product of of the position of the radius and also the angular and also the linear momentum. Ndio definition yake, lakini tunajua linear momentum ni sawasawa na nini? The linear momentum, my dear student, is represented by symbol P, ambao P ni sawasawa na mv, while m represent the mass of that body, while v represent the speed of that body, my dear students. Now this is how we can say about the linear, about the angular momentum. Therefore, we could say the angular momentum must be equal to the cross product of the radius times the linear momentum. And this will be our equation number 91 for our fourth topic here. So the magnitude of the angular momentum is given by PR sin theta. We get the magnitude of the angular momentum by taking PR theta. Kwa tukiulizwa kutafuta magnitude angular momentum, tutamwambia magnitude ya angular momentum ni sawa na PR theta, where P represent the linear momentum and the R represent the radius of that bolt, where this theta here will be the angle that will be the angle between the P and also the R. Kwa huyu atakuwa ni angle ambayo ataact kati ya ile P, kati ya linear momentum pamoja na ile distance au radius ambayo tutakuwa tumepewa. So consider a particle A at a distance R1. Now imagine we have the particle, and that particles we have the particle A, and that particle A having the distance R from the axis 0 of rotating of a rigid body. If we have the particle, and the particle is labeled by the letter A, having the distance R1 from the axis of rotation of the rigid body. Now the body rotates with the angular velocity. If the body trying to rotate on it is an axis, it rotates with the angular velocity kama tunavyoiona W here. And the figure that is indicated for the next slide trying to explain about the angular momentum. Let us go and observe this figure here. So our figure, as we try to see, that is like the rigid body, but this figure explaining about the angular momentum and also the moment of inertia. Kwa hiyo ni figure ambayo inaelezea kuhusu angular momentum pamoja na moment of inertia, my dear students, as we try to see for our discussion here. So this is the rigid body, my dear students. But this rigid body trying to rotate about the axis of rotation. Kwa hiyo inajaribu kurotate kwenye axis of rotation, lakini inapokuwa ina rotate na follow the direction of the angular velocity. Kama tunavyoona angular velocity inaonyesha direction ya hii rigid body. Inside the rigid body here we have the particles. We have particle A, we have this particle A, and also we have the particle B, as we try to see. Also we have the center. This is the center O, and also we have the axis of rotation. From the center O up to the particle, up to the point A, where the particle A is located, will be represented by the distance, kwamba ile distance ya kutoka kwenye hii center of the axis of rotation mpaka kwenda kwenye particle A hapa itabini expressed by R1. But this particle A here, my dear student, it having the mass 1. Kwa hiyo hapa particle inakuwa ina involve the mass 1 pamoja na yule angular momentum ambao tunamuita the angular momentum of the particle A, R respect to A. L respect to A. So let us come back for this point B. At the point B here, this expressed as the particle at the point B, the particle B. Kwa kwenye particle B is allocated with the distance kutoka kwenye center pa kwenye particle B in allocated with the center with the radius R2. Kwa hiyo tunaona kuna radius R2 yake. Lakini my dear student here, as we try to see the particle B here also contain its mass, tutaita ni mass 2, na pia ina angular momentum ambayo tunaita ni LB as we try to see. So this structure here explain about the angular momentum, my dear student. As we see that we have the rigged body, but this rigged body involves the two particles, and each particle having their angular momentum. Particle A having the angular momentum A, and also particle B having the angular momentum B, or R respect to B here.